Hi everyone! The goal of this video is to learn how to do what's called linear regression with our graphing calculators. Our objective says that we are going to interpret the data to make predictions and decisions, but we're actually going to save that for class. All I want to do in this video is kind of explore the TI graphing calculators and make sure we're comfortable enough using the tools so we can do an investigation in class. What we're going to do today is actually a statistics topic. So the goal is to analyze a set of data and use our graphing calculators as a tool to develop different relationships with the data. So the data we're going to analyze today is the relationship between total fat and total calories. The question we're pondering is there any relationship between the total fat and the total calories? Or more specifically, is there a linear relationship? Or how linear is this data? So is it that the more fat you have, the more calories you have? Is it that the less fat you have, the more calories you'll have? And we're going to try to analyze that. And our graphing calculators are a really good tool to do this. So if you have your graphing calculator, please take it out. You may have an 83 or an 84. My simulator is an 83, so that's what I'm going to be doing this on. Now, in order to enter any data into your calculator, once your calculator is on, you're going to go to the Stat button. So, since this is a statistics topic, everything's going to be in the Stat function here. If you want to edit things, it's in the Edit column. If you want to calculate, it's in the Calculate column, and we don't really use the Test column in this class. So to enter data, I'm going to go to Stat, and I'm just going to go to Edit. And you should get a table that comes up. I'm just going to put one of my variables in L1 and the other variable in the L2. So let's call this like my x's and these are my y's. I'm just going to enter x's in the L1, y's in the L2. Now, if you have anything already entered into your graphing calculator, if you hit the arrow up and hit clear, it will clear the entire column. Since I don't, it didn't do anything. In order to enter stuff, you're just going to select the number. So something like 6.5 is my first quote-unquote x value, and hit enter to get it set into the calculator. And just continue this for the rest of the column. So I'm going to pause my video just so I can get it entered. I want you to enter the entire total fat column into L1 on your own calculator. Okay, so now I have all of my total fat grams entered into L1. I want to go enter my calories into L2. So to get there, you just hit the arrow to the right. And you're going to do the same thing. So I'd enter 190 in the first spot, and make sure 190 corresponds with 6.5 like it does in your actual chart. So one of the common mistakes I see is people just go in quickly and not entering the right thing. So be careful and double check that you have the right amount of information and it's in the right spot. So I'm going to pause and enter that in my own calculator. Okay, so now I have all my data entered into the calculator. If you did it correctly, you should have them lining up at the end with 19.5 and 550. So now that my data is entered, I can actually calculate things and figure out some information about this scenario with the total fat and calories of Chipotle menu items. So quit out of that by hitting second quit. Now before you calculate anything, in order to do this successfully, you have to have what's called the diagnostic function turned on. In order to do that, you go to your catalog, which is above the 0 button. So to get there, you hit second 0 and find catalog. Now this is in alphabetical order, so D would come kind of far down. Instead of scrolling through the whole time, you can just hit the alpha button to get the letters and hit the D letter, which is above the X inverse. And then you'll be in the D's, so it'll be a little bit easier to find that diagnostic button. So if your diagnostic's off, some of the functions won't work correctly, so always make sure it's on before you start the linear regression. So I highlight the on, I hit enter to actually turn it on, and you're good to go for the rest of the problem. Now that we've taken care of that, I want to figure out what I can do with this data on my graphing calculator. So the first thing you can do is you can get a visual. So if you want a visual, I want to graph this data. Now, as you're looking at my window, we may not be able to see this data, so I want to adjust my window to fit the data. So in terms of my X minimum, my X's are my total fat. We don't really have any negative fat, so I'm just going to make my X minimum 0. My largest X value is 27, so maybe I'll make my X maximum 30. Okay, I don't want to change my scale, but I do want to change my Y minimum. I can't have negative calories, so I'll make that 0. My largest Y value is 570, so maybe I'll make my largest Y value, I don't know, 580, or you can make it 600, it's up to you. When I hit graph, I should be able to see this data entered in, but I don't, so I wonder why that is. Normally when you graph a function in your calculator, you're graphing an equation, a y equals. What you're graphing now is a data plot. It's a set of data. In order to do that on your calculator, you have to basically turn the graphing part off and turn the scatter plot on. And what I mean by scatter plot is when you take a set of data, it's just kind of all over the place. It's not necessarily a function, it's just a set of points. So all of that is in your stat plot function, which is above your y equals. So I'm going to go to stat plot, should come up looking like this. And right now my stat plots are off, so I won't be able to see a scatter plot. I want to turn that on. So highlight the on, hit enter, should move over, and then your scatter plot's on, and you should be able to see the graph, which I can now. Okay, so now my calculator has graphed this data, which this is the x and this is the y. Now that I've got a visual, I want to create a line of best fit. Now, a line of best fit is just a line that most closely relates to the data you have. So it'll be a line that helps you make predictions in the future. In order to do that, we're going to go back to the stat function, but instead of editing, we're going to calculate things. Linreg means linear regression. That's the function we're going to be using for this problem because we're doing linear regression. We want to see what's the line that best fits this data. That's why it's linear. So you can scroll down to 4, or you can just hit 4, and then linear regression should pop up. Don't hit enter yet. If you have a TI-83 like I do here, you have to tell your calculator where you entered the data. Because if you remember in that stat function, you had a bunch of columns. I had an L2, I had an L3, I had an L4. So your calculator needs to know which one you're using. Let me quit out of that. So the one I was using is L1 and L2. In order to find the L1 and L2, they're above the 1 and 2 button, but you have to hit the second button. So I have to tell my calculator I entered my x's in L1. Then I have to separately tell the calculator I entered my x's in L2. So you'll hit the comma and enter the L2. If you have a TI-84, a screen may pop up that already has L1 and L2 entered. You'll see that on the sheet I hand out in class, what the visual of that looks like, or you're seeing it on your calculator hopefully right now, but you may not have to edit it as I did. If it doesn't say L1, L2, you're going to have to enter L1, L2 where it says your inputs and outputs or whatever it says. The last thing I want you to do is I actually want to store the line of best fit. What I mean by store is right now you're just going to calculate it. So it's going to give you an equation. But if I want to store that into y equals so it graphs the line in your calculator, you have to tell your calculator to do that. And the way you do that is by finding the Y1 button and assigning the line to Y1. And that Y1 button is in this button that says VARs, variables. So we go to VARs, and we want to go to Y variables, because that's where all your Y equals are. And if we store it into Y1, what that really means is you're going to put the equation they give you and put it into Y1 here. Now that you have all that entered, hit enter, and it should give you the information you need for the line of best fit. So your graphing calculator says y equals ax plus b. Your a, in this case, is your slope. Your calculator likes alphabetical order instead of using mx plus b. It means the same thing. So a is your slope, b is your y-intercept, and r squared we don't really use in this class, but r is your correlation coefficient, which we do use in this class. So now that we got that information, we would go ahead and interpret the data to make decisions and predictions, which I love this topic. It's one of my favorites because it's extremely useful to be able to take a set of information and come up with a relationship between it, and that relationship can help you say, okay, if I had 30 fat grams, how many calories would I have? We could make a prediction by analyzing the trends. We are not going to do any analyzing in this video because that's what I want to work on in class. But I do want to just kind of talk about briefly what you see in your graphing calculator one more time. So your graphing calculator gives you the line of best fit is y equals ax plus b, where you just want to go ahead and fill in the information. So your a would be 17.69, and you can plug that in for a. I'm just being lazy. And your b is 45.36. I say 45.36, yeah. So you would plug those in and get your line. Your slope, again, is your A, your y-intercept is your B. Your correlation coefficient is that R, so you can write that vocab word down. This R value tells you how strong of a relationship your data has. When I say strong, I'm really saying how closely related are fat calories and fat grams and calories. So there's a couple things you can look at from your R. Your R can either be positive or it can be negative. Positive means there's a positive correlation. Negative means there's a negative correlation. So positive meaning as your X rises, your Y would also rise. Negative correlation would mean as one variable rises, the other variable decreases. Or as one increases, the other one decreases. So it's kind of like a positive or negative slope. Okay, then your R can also be close to 1 or close to 0. So your R value will be in between these two numbers, or between -1 as well. The closer your number is to 1, the stronger the linear relationship is. So if you have like 0.97, it's almost linear. If you had a 1, it would be linear. So I'll just say strong relationship, but you could also say strong linear relationship. And the closer your number is to 0, you have a weaker relationship. So a 0 as a R value would say to me, like, there is no relationship between the data. Like, it is just all over the place with no rhyme or reason. Whereas being closer to 1, your data might look like my red dots, where you're almost linear. Maybe there are a few outliers, but the closer it is to 1, it's going to be linear. If it is 1, it's a perfect linear relationship. So that's all I'm going to give you for today. In class, we are going to analyze another context where you have to use this information, you have to use this technology to interpret some information and make predictions or decisions. So I hope after this video you feel comfortable using your graphing calculator. If not, I'm also going to give you some really great step-by-step instructions to use. So expect that when you come to class. Otherwise, have a good night.